Today we're going to be looking at 8.5, which is infinite geometric series. There are two different types of infinite geometric series. The first one is what is called a convergent series, and the second is a divergent series. So what we're going to do is we're going to look at these two series. There's similarities and differences. A convergent series has an infinite number of terms whose sum approaches a fixed value. And a divergent series has an infinite number of terms whose sum does not approach a fixed value. If you were to graph the sum of these compared to the number of terms, a convergent series is going to do something like this, where this is that fixed value. And you can see that this is going to be the sum of one term, sum of two terms, sum of three terms, so on and so on, that it does hit a fixed value. A divergent series, on the other hand, will do something like this. It reaches no fixed value. Sum of one term, sum of the two terms, sum of three terms. Examples of these: a convergent series is 1 plus a half plus a quarter plus an eighth. And for divergent, you are looking at 3 plus 9 plus 27 plus 81. The main difference between these two is the common ratio r. So if you remember, r is calculated by taking the second term divided by the first term. So looking at a convergent series, we can see r is 1/2 divided by 1 and a half in this case. In a general sense, r is -1 to r. So r is between -1 and 1, or can also be written as the absolute value of r, which is less than 1. In a divergent series, r is greater than 1, or r is less than 1, less than -1. The formula for a convergent series is the sum of an infinite series, so that's just an infinity sign there, is equal to a over 1 minus r, a being the first term, r being the common ratio. There is no formula for a divergent series, and the reason there isn't is you cannot calculate a divergent series sum. So you cannot calculate Moving on to our examples. So we're going to start very basic here. We're going to look at a set of series and decide whether they are convergent or divergent. So if you're asked something like this, what we're asking you to do is figure out what r is. So remember, r is t2 divided by t1. So that's -1/3 divided by 1, which is -1/3. Remembering that to be divergent, you must be between those bounds of -1 and 1, which this is. So this first case is therefore divergent. Okay, I would like you to try B. So just take a quick second and look at 2 plus 4 plus 8 and decide whether it is divergent or convergent. So pause and try it. Okay, now that you've unpaused this, let's look at r. We know that this is t2 divided by t1, which is 4 divided by 2, so r is 2. That is greater than 1. So since r is greater than 1, the series is divergent, which also means that you cannot calculate the sum. Our last one that we're going to look at here is -1 plus 1, -1 plus 1, so on and so on. R is t2 divided by t1, 1 over -1, which is -1. This is neither convergent or divergent. And the reason it's not either is because the R value is equal to that boundary of 1 or -1 in this case, and therefore it doesn't fit the definition of divergent or convergent. Example 2. Determine the sum of a series if it exists. So let's look at the first one. Let's just get rid of that out of there. First thing we need to do is determine whether this sum exists, which means that we have to decide whether it's convergent or divergent. So let's look at R, T2 divided by T1, 5/10, which is 1/2. This means it is convergent because it's between -1 and 1. So because it is convergent, we can use the formula. The sum of an infinite series is A over 1 minus R. Substitute in there. A is 10, 1 minus 1/2. This gives us 10 over 1/2, and that gives us a sum of 20. So if you're to take your calculator out and add this series up, it will eventually approach the value 20 and will become 20. Looking at the second series, we have 1 plus 1/5 plus 1/25. And I should mention at this point, these ... dots there represent your infinite series. Okay, pause this video right now and let's try this series, deciding whether it's convergent or divergent. If it's convergent, then calculate the sum. So go ahead and do that now. Okay, welcome back. We're looking here. Let's calculate R, T2 over T1, 1/5 over 1, which is 1/5, convergent. Therefore, we can use the formula, A over 1 minus R, substitute in. A is 1, 1 minus 1/5. This is 1 over 4/5, which is 1 times 5/4, or 5/4. So the sum of this series is going to be 5/4. Looking at the last one, again, I would like you to try this one. Find the sum of this. So pause the video and go ahead and find that sum. Okay, so let's look at this video now, let's look at this question now. Calculating R, T2 over T1, 20 over 10, which is 2. This is divergent, therefore no finite sum. Okay, repeating decimals as fractions. This is a concept that you would have touched upon in grade 8, way back then. Looking at, let's just get these repeating. Looking at these questions here, we'll look at the answer here. So this is going to be 7 over 9, and the general rule is if all the decimals are repeating, then you just write it over the appropriate number of 9s. So this one would be 9, and because both the 6, 5, and 5 are repeating, it's 65 over 99. This one would be 2 over, and we have 2 decimal places there, so 2 9s, 2 99ths. So let me just put a little note there for you. If all the decimal places repeat, just write over the appropriate number of 9s. So those are easy ones, right? Moving on to something a little bit more difficult, you can see here that we have 0.72 repeating, not the 7 and the 2, but just the 2. So this is essentially doing something like this, and so on, so on, so on, so on. Okay, so looking at this one, we know that this is equal to 0.7 plus 0.02, that gives you the 0.72, plus 0.002 plus, and this is going to continue on. Why this is in the infinite geometric series is if you look at this right here, this is an infinite geometric series. And we know that in this one, r is equal to 0.02, sorry, that's 0.02 divided by 0.02, which is 1/10, if you work that out. So this tells us it is convergent, therefore we can find the sum of that infinite geometric series. Looking at the sum, we know that this is going to total a over 1 minus r, a being 0.02, 1 minus 1/10. I'm just going to convert everything into fractions, so this is a 50th divided by 9/10, a 50th times 10 over 9, and that works out to be 1/45. What we then have is the non-repeating part, which is 0.7, plus the repeating part, which we've worked out to be 1/45. Converting everything to fractions, 7/10 plus 1/45, and that is going to work out to be a common denominator of 63 over 90 plus 2 over 90, 65 over 90. Divide everything by 5, and you get 13/18. So if you were to take your calculator out right now and go 13 divided by 18, you would receive that decimal number there. Okay, moving on to the word problems. The arc length of an initial swing of a pendulum is 50 centimeters. On each successive swing, the length is reduced by 20%. How far will it swing altogether before it stops? So a pendulum is just like a grandfather clock motion. It's swinging back and forth, back and forth. Each time it does that, it's losing 20% of its distance. So the key here is this is being reduced by 20%. That tells us that r is 0.80. Okay, so it's losing 20% but keeping 80%. Therefore r is 0.80. We start at 50, and to go from the first term to the second term, you're just going to multiply by that r. So that's going to be 40, and you just can keep doing this. So because this is a convergent series, we can use the formula. The sum of the infinite series is a over 1 minus r. A is 50, 1 minus 0.8, and that is 50 over 0.2, which works out to be 250 centimeters. So this pendulum will swing a total of 250 centimeters before it comes to a stop. Our final question for today is another one of the bouncing ball questions. So this one, a ball is dropped from a height of 16 meters and it rebounds to half its height. Find the total distance the ball has traveled. So I am going to show you a number of different ways to calculate this one. They're all relatively the same. It's just a matter of coming up with different starting points. First thing I like to do is just do a quick little diagram of what's going on here. So we know that this is going down, up, like this, and it's going to keep doing that until it comes to a stop. We know that this is a total height of 16 meters. We also know from this that it's rebounding to half its height, so R is 1/2. Oops. Let's keep the question there. Okay, so we know that because R is 1/2, we can use the infinite series formula. A over 1 minus R. So let's look at what A is. So I'm going to start with A being 16. If you draw this, you could think of it as that way. So you've dropped it from 16 meters down to the ground, and then its next height that it's going to reach is 8 meters, and then 4 meters, 2 meters, 1 meter, half meter, so on and so on and so on. What we have on this one is the sum of the infinite series is equal to 1 minus 1/2. So 16 divided by 1 minus 1/2, which is 16 over 1/2, which is 32 meters. But that only counts the downward traveling distance. So what we have to do is we can take this value and multiply by 2. If you multiply by 2, what that does is it puts in the upward distance that the ball is traveling. But at the same time, it also puts in that upward distance. So 32 times 2 is 64, and then we have to subtract out, let's use this one, we have to subtract out that because we dropped it from an initial height of 16. So subtract the 16 and you get 48 meters. Okay, let's look at A equaling 24. So the story behind this one is that is your first bounce and your first upward motion. So this is a total distance of 16, and this is a total of 8 back up. 16 plus 8 is your 24. And we know that it rebounds half the distance from 16, so that's where the 8 meters comes from. So that is A, and then this just repeats. And we can look at this one as the sum of the infinite series is 24 over 1 minus 1/2, 24 over 1/2, and you can see that that works out to be 48 meters also. The third way that we could look at this question is where A is, let's do A is 32. So in this one, what we have is instead of dropping it from a height of 16 meters, we're starting at the ground and it's going up 16 and back down 16. So there's its total distance of 16 meters up and 16 meters back down. So there's your A is 32, and then it just keeps doing that. So in this one, we have 32, 1 minus 1/2, 32 over 1/2, which is 64, and we need to subtract out again this 16 meters on the initial upswing because it didn't actually travel that, and you get 48 meters. And that is probably the 3 best ways to calculate this question. Any one of those 3 methods is fine as long as you're showing your work properly and you complete it with a diagram. That ends 8.5, Infinite Geometric Series. Up next will be sigma notation, which is actually not part of the workbook. It's not a specific chapter, but it's embedded within all of the other sections, so that will be the next video lesson. Again, thank you, and we will see you later.